Next, we're going to talk about the phases and classification of matter. So matter is anything that takes up space and it has mass. And there's the three most common states of matter: solid, liquids, and gases. Solids are rigid, they possess a definite shape, and liquids flow and they take on the shape of a container. And a gas takes both the shape and the volume of the container. So as a gas is filled in a closed container, it will fill the container completely, and it will look something like this. It expands to fill the container. And I'm sure you're familiar with these three different phases of matter. The fourth state of matter is plasma, and it's a gaseous state of matter, and it has electrically charged particles. So when plasma is typically found on the sun, and it is found on Earth in very things that are very hot. So like we have a plasma torch. We also have some plasma that can be in, if we just light a fire, that's a form of plasma as well. So they're all in high temperature environments. This is a plasma torch that can cut through metal. So this plasma torch is cutting through this thick piece of metal here. Mass versus weight. So mass is the amount of matter that's in an object, and weight refers to the force of gravity that is exerted on that object. Mass, we typically talk about weight and mass interchangeably in chemistry, because most of the things that we're doing in chemistry uh, involve experimentation on planet Earth. Um, so our weight changes on different planets, or it technically can change at different altitudes at very small amount. But when we say mass or weight, sometimes we'll say those things, those words interchangeably in chemistry. The law of conservation of matter says that the total quantity of matter is always going to be the same. So this is true for chemical changes, and it's true for physical changes. So no matter what is happening in a chemical reaction, we don't lose any matter. Now, we might lose some due to heat, um, and later in this course, we will be talking about thermochemistry and how heat loss is going to work. But for the most part, we're going to just be focusing on closed systems where we're not losing any heat energy. And that means that all matter is conserved, and nothing is lost in the chemical reactions. So this is an example of conservation of matter. This is as they're producing this beer. There's pre-beer and sugar, and as it mixes together, it forms a carbonated substance of beer and ethanol. And this what's happening here is no matter is being lost. And we can also see that in this example with uh, these these lead acid batteries, where the production of electricity is equal to the mass of the lead and the water that's formed. So what's happening here is we're not losing any matter overall. All right, so here are the practice assignments associated with this part of the lesson.